folks, and welcome to this lesson on the organic nomenclature of amines and amides. By the end of this lesson, you should be able to name and draw compounds that contain amines and amides. This is going to be our last lesson in the series of organic nomenclature, and for this last bit, we are going to be looking at functional groups that contain nitrogen. Now, unlike your oxygens, which can only really form two bonds, nitrogen can typically bind with 3 species, and so some of this is going to change the naming that you are going to see. In terms of intermolecular forces, you can have quite a bit of variety in there because there's so much potential for branching, you even have the potential for hydrogen bonding in there, and so you really have to see at how everything is put together to be able to tell if it's going to have super strong intermolecular forces or if it's not going to be that strong. So first off are our amines. These are the ones that have nitrogen in them, and they are single bonded to other things. These other things are going to be either hydrogen or carbon. The group is referred to as an amino group, and if you do have hydrogens on there, it is theoretically capable of hydrogen binding, or rather bonding. When it comes to the nomenclature of amines, IUPAC only names amines as side chains, and so you're never going to have an amine as your most important functional group. It's going to look very similar to how naming happens with those alcohols, and you're going to name it with the name of amino. Now, looking at that word amino, that might trigger some other knowledge in your brain, that of amino acids, which you may have heard of before. And yeah, amino acids basically have an amine group and a carboxylic acid. That's what makes amino acids amino acids. There is that possibility of more side chains being connected to that nitrogen. If that's the case, what you're going to do is name all the other stuff as side chains as well, but instead of using a number, because it's attached to the nitrogen, you use N instead of that. But if I'm going to be honest, you're not going to see a whole bunch of this. So here you go. Pause the video and see if you can figure it out. There's a whole bunch of stuff going on in this particular compound. The important bit is, did you figure out the most important functional group? If your answer is that it's that carboxyl group, then you're correct. So highlight your carbon chain, longest chain that contains that group. Let's look at our side chains. So I guess before side chains, numbering. Numbering is going to start from the right because that's where that carboxyl group is. We end up with an amino, a methyl, and a methoxy group in here. From here, we're going to start naming. Start with our side chains in alpha order, then the name of our parent chain. And so with this, we end up with 2 amino, 4 methoxy, 4 methyl heptanoic acid. And our last one, our amides. Your amide is going to look sort of familiar because it has some similarities with your esters. You have that carbon that's double bonded to an oxygen, but instead of another oxygen, it's going to have the nitrogen. This whole situation is referred to as an amide linkage. You may have guessed it, but it is made from reacting a carboxylic acid and an amine together. And when you're thinking about proteins being very, very long chains of amino acids, yes, they are long chains of amino acids, and they are connected by these amide linkages. So the amine part of an amino acid is going to react with the carboxylic acid side of the amino acid, and then you just have long chains of all of them because your amino acids have both, and so it's just going to continue and continue and continue. Intermolecular forces are going to be weaker than the carboxylic acid, which is nothing new if you remember the stuff about the esters. The naming of amides is going to look fairly similar to the naming of an ester. The parent chain is a side that started out as a carboxylic acid. If you have R groups attached to where that amine was, like with your esters, you are going to put those bits first in the name. But the one difference is that with your esters, you didn't have to write any numbers for that part of the side chain, But in the case of an amide, you are going to put N in front of it. And then there is a space and so on and so forth. And the suffix is amide. And again, numbers are not needed for the amide bit of the name. So here you go, pause the video, see if you can figure it out. So the carbon that has the oxygen double bonded to it, that is going to be that carbon that starts that parent chain. So here is our parent chain. Numbering starts at the right because that's where the amide linkage is. We have a few bromos in here and nothing attached to the nitrogen. So when we put the name together, it's going to be 2,3-dibromobutanamide. Here's another one. See if you can figure this one out. So once again, look for that carbon double bonded to the oxygen to figure out your parent chain. Now this time we do have some side chains on that nitrogen, though we don't even have any side chains on the carboxylic acid side of things, so we don't actually have to worry about numbering this time. So when you put all of this together, you're going to have that methyl and ethyl come first. And after you put in your N-ethyl and methyl, don't forget about the space, because again, these are attached to the, these are amide things, so not part of that parent chain, so there has to be that space. And then the butanamide. So once again, this whole thing ends up being N-ethyl and methyl space butanamide. And lastly, in terms of the drawing, there's nothing super special about it. When it comes to those amides, though, I would probably say use the same advice as when you were drawing esters. And that's the end of this lesson. I'll see you next time.